Human beings are political in nature, and ever since the advent of democracy, election is one of the ways by which we ensure free, fair, credible, and transparent ways of putting people in position. The current system is majorly ballot system, where you have the parties on paper and people go there, get accredited, and start voting for each of the parties they want. But why don't we use a real-time system? A real-time system ensures instant and real-time visualization of what is going on in each location, as well as for each of the candidates in the process. At the end of the day, the winning candidate will be crowned the winner of the election, and the election will be free, fair, and credible as well. In today's video, we are going to be building a real-time election voting system, where we are going to perform the accreditation of voters, the candidates and the parties, as well as the voting system itself. Everything done in real time. And once the voting is concluded, we are going to see the winner of the election. So let's go over to the architecture session and let's get started. So let's take a look at the system flow. In the system flow, we have a couple of parties here. So we have the management party, and we have the savior party, and we have the Tech Republic party. Now, each of these parties already did their primaries as expected, and they nominated the candidate that is going to be going for the election. So this management party nominated this man, the savior party, this woman, and the Tech Republic, this gentleman here. Now, each of these candidates will be passed through a rigorous voting process that is going to be conducted on the platform. And eventually, we are going to have a winner. And how are we planning to overcome this challenge? How are we planning to do the implementation of this code? All right, so we are going to start by going through the architecture of the system. And the system architecture looks like this. We are going to have the parties, the candidates, and the voters that are registered on the platform. Now, each of these guys are going to be more like an entity that is going to be saved into PostgreSDB. Each of these people that are saved, I mean the parties and the candidates and the voters information that are saved on Postgres, will also be immediately streamed simultaneously into Kafka. Once data gets into Kafka, we are going to have a Spark job that is going to be listening for events that are coming into Kafka, consuming and aggregating that, and streaming back into another topic on Kafka. On the visualization end, we are going to have Streamlit that is going to be also listening for events that are coming in to Kafka topic that is listening on, and then visualizing that in real time. So we are going to be seeing how each of these candidates are going to be overtaking each other as voters are voting for each of them. So this is the architecture of the system we're going to be looking at today. So let's switch over to the coding section and let's get started. I'm going to start by creating a new project. I'll call this real-time voting engineering. Okay. Now I'll be using Python 3.9 and using the VAMV that is created by Python. And I have a main welcome script. Well, I don't need this for now, so I'll just uncheck this and create. Now it takes a few seconds for the bootstrapping to be done by PyCharm, but once it is done, we can easily get started. Now I'll just minimize this a little bit, reduce that, and then fire up my terminal in here. And I will try to also increase the size. So let's start with the main.py. I'll just try to increase the size a little bit. Let's see. Yeah, I'll just cap it at 20. Good. We need to get in the packages that we're going to be using. So we are going to be needing to access Postgres. So we need to install scopg2 binary for us to have access to Postgres. We are going to be needing Confluent Kafka to communicate with Kafka, and we are going to be needing simple JSON for our JSON deserialization and serialization. And I think we can start with this ones. If we need any other ones, we continue. We install them and we continue from there. Okay. Now, so once this is done, we're just getting the architecture of the system. So I'm going to do the docker compose.yaml. And I already have an architecture in mind, so I'll just copy paste that and I can talk through it. So in here we have, I'll just remove the volumes in here. So in here I have the zookeeper, I have the broker, the Postgres, and the Spark master and worker, right? So I'm going to start with the zookeeper. So the zookeeper is using the Confluence CP Zookeeper 7.0, 7.4.0, and I'm exposing that on port 2181. This is the edge check because of the dependency that exists between the zookeeper and the broker itself. So for the broker, we have this CP zookeeper, and I'm exposing 9092 and 9101, as well as this zookeeper connect on this URL. The listener and the advertised listener protocol map is going to be plain text and this guy, and the rest are just replication factors majorly. Now, on the other hand, we have Postgres. I'm using Postgres, latest Postgres. I think that's Postgres 15 as of the time of this recording. And we have the port 5432 as the exposed port. The environment is Postgres, and I'm calling the database name, voting. So let's bring in edge check in here. And if you want, you can also get in the Spark master worker. But because of compute, I'll be commenting this out for now. Maybe I'll just uncomment it. If the compute is getting utilized over the threshold, I'll just comment it out and delete them. But this is the master worker architecture. I'll just have my command in here as my master and exposing the port. And the worker is going to be on 7077 and listening to the master. And this is the Spark master URL. By the way, it's using a worker memory of 1 gig and 2 cores. Okay, just a single worker is here, but if you want to have multiple worker, this can be duplicated and replicated. You can check the video in the card. Just in this video, you'll see how I replicated multiple workers and we are able to use multiple workers. I'll just stick to one worker in this video. Okay, so the next thing is to bring up and fire up our Docker instance and take this for a spin. Okay, so I'm just going to Docker. I'm bringing my Docker. Okay, now I don't have any container running, which is good. So the next thing is to fire up this container. I'll do docker compose up and detached. So it's going to pull in the Spark master worker, and each of these guys are going to be spin up in a system. I'll just pause and play until it's done. Once that is done, we continue from there. Now, all our master worker and the other architectures have been set up. So we have our container started, Postgres zookeeper, the worker also started, and the broker with the Kafka broker is also created and started. So let's see how that looks on the Docker container. So it looks like this. And right now, all of them are running. The broker is still created. I think it's waiting for zookeeper to be ready to accept connections. And once that is done, the broker also will get started. Right now it's done. Good. So this is a good start. We are not going to be using the control center because there is no need to visualize so much on the UI. I'll just use the CLI for that. And from there, you can also, pick up the commands to relate with Kafka on the CLI. So we can go back to the broker in here and check if we do Kafka topics, and then we do a list and we pass in our bootstrap server. And the bootstrap server is broker 29092. That's the port that I exposed internally, and there's no topic. So this means that everything is fine as of this moment. We are able to query the list of topics, even though there is no topics. But it's good that we are able to see that our broker is accepting connection, and we are able to run our commands. Good. Now, going back to the code, we go to our, once our architecture is set up properly, we go back into the code and get started with the actual coding. Now, we are going to start with the main.py. In our main.py, this is where we're going to be generating the voters information, the candidate and the party information, everything saved into Postgres. Of course, we're going to take care of the, creating the tables on Postgres. And if we run it multiple times, we don't want it to be crashing. So we are going to be sure to handle that use case by the time we are running our code. So let's do that. Now, I'm going to just start with if name equals to main. Now in our main function, this is the entry point of the application. I'm going to, something is here, but I'll just disable the autocomplete by our favorite Copilot. Thank you, Copilot. So I'm going to start with the connection. So I'm going to be importing the scopg2 scopg2 package, and I'm going to be connecting based on that. And you can see the import is automatically done. So here I'm going to be getting the host. The host is going to be localhost. The DB name is going to be voting. The user is going to be Postgres, and the password is going to be Postgres. Okay. Now, once this is established, potentially we are going to have a connection established at this point. You can do this in a try except just in case there's an error. I'm just going to do that right here, except, and we can say exception as E. If there's an error, print E. Okay, good. So we've handled these connection errors at this point. So let's get our cursor into the system. Cursor is going to be connection.cursor. Now the cursor is going to allow us to, connect to Postgres, create tables, get our queries run and get the result from Postgres. Okay. So now the first thing we want to do is create the table. So we are going to have create tables, and I'm going to be passing in the connection and also the cursor itself. So let's create a table function. So dev create tables. I'm going to be passing in the connection as well as the cursor. Now this is where we are going to be establishing our connection with the DB and creating the table. So I'm going to have cursor.execute execute. And the candidate ID. So I'm using a composite ID in here. So to ensure that we have just one voter ID and one candidate here. And the voter also must be unique at this point. We can have multiple candidates, but we can just have one voter. Good. So the primary key in here, just command this. Okay, the primary key in here is the voter ID and the candidate ID. Of course, the composite ID. So now finally, we just do connection.commit. And this should create a table for us on our Postgres. So far, everything is fine in here. What's the error message in here? Yeah, it's fine. We can just reformat that and we should be good. Now, I'm using the if not exist command in here. So in case we run it multiple times, so we don't recreate this table, thereby returning an error that table already exists and all that. So if you don't add this to it, we are going to have an error by the time you are running that. Good. Okay, so now we've been able to create our tables. So now we can continue. We can say for you to vote, we need to get the candidate you want to vote for, and we want to be able to create this candidate in the system. So we get the candidates that are affiliated to a party, and each of these candidates will have voters voting for them. So right now, the first thing is to get in the candidate as well as the party. The voters will come in subsequently. So we have the candidate. It's going to be I'll put this as an empty array for now. So let's get in our cursor to cursor.execute. So to execute a command to check for select star from candidates. Okay. Now this gets all the candidates in the system for us, and then we can just say cursor.fetch all. Now this gets source all the candidates that are in the system. So if you want to see that, you can say fetch print candidates. Now this is going to print the candidates for us. Now if the candidate has not been registered before, if the length of candidate is equals to 0, that means we don't have any candidates registered in the system. So let's register the new candidate. So I'm going to have I in range of 3. And this could be the logic that's going to be handled on the UI, but I'm doing everything on the back end. So I'll just limit it to 3 candidates. So I'm going to have candidates is going to be, let's say, generate candidate. All right. So I'm going to be passing in the current index, which is the I in range. So I'm going to be passing in the index and the total parties of 3. So let's let me generate candidate data. In here, I'm going to just have dev generate candidate data. So I'm going to be passing in the index in here as well as the total parties, which is going to be more like candidate number. Okay, and the total parties. Okay. So now we are going to be getting this information, like I said earlier, we're going to be getting this information from randomuser.me. So we have our response is going to be a request to just import this. Okay, I think we didn't import request pip install request. Okay, so bringing request in, I'll just import request. Okay, so I'm going to be doing a get request to the random user API. So let's get the API into the system. So if you look at the documentation, you can actually specify some stuff into the API. So I'm going to be putting in my base URL. I'm going to be putting in the HTTPS as a string in here, and it's going to be random user.me/API, and I'm going to be using the nationality of the Great Britain. Okay, now let's get in the parties as well. The parties that we're going to be working with today are management party, savior party, as well as the Tech Republic party. Okay, now for us to have because we're going to be using something like a random to be generating the data, so for us to have something unique each time we run it and the same record being returned, we're going to seed our random. So I'm going to just say random.seed, maybe 21 or something like that. Okay, and let's import our random. Import random. Okay, going back to our code where we're generating the candidate data. So where are you? Okay, yeah. Okay. I get the base URL in here, base URL, and I'm going to be passing in the gender. So I have, if you look at the flow in here, I have 2 males and 1 female, right? So, and I already know the total parties in here. So I just need to pass that to the query parameters. So I'm going to say, and gender is going to be plus female. If it is if it is, I'm going to be starting from 0. The index is starting from 0. So if it is odd number, I'm going to be creating a male. If it is even number, I'm going to be creating female, if that makes sense. So if candidate number percentile 2 equals to 1, that means it's odd number, maybe 1, 2, else I'm going to be doing male. So this is going to get us 2 males and 1 female. Okay. So I have response dot status code. If it is equals to 200, I'm going to generate the user data, and I'm going to say the response.json converts that to JSON, and I get in the results. Okay, I get the first index of that. Now this gets us the user data, and I just say a return of the candidate ID in the structure that I want. Return the candidate ID of the user data. Going to be the login UUID. Well, you can use maybe a random user ID for this. I'm going to have candidate name. It's going to be let's say a formatted string of user data. I get in the name, of course, the first name. You can look at the documentation, if you want to get into the nitty-gritty of how the structure looks like. Just to save time, I'm just going to continue with this user data. Okay, I get in the this is going to be double quotes. Okay, yeah, so user data, I get in the name as well as the last name. Okay, then the party affiliation is going to be the parties in here, and candidate number percentile, the total parties. This is going to get us 0, 1, 2, 3. Okay, then the biography of each of the candidates. I'll just put a brief biography of the candidates. Okay, then the campaign platform is going to be, let's say, your key manifesto in here, key campaign promises and or platform. Okay, then finally we have the photo URL, which is going to be the image of the candidates themselves. So the user data, I'm going to have the picture, and I'm using the large picture. Okay, so if you are confused as to how I'm getting this, you can look at the documentation and the results that are coming in from this JSON data. You'll be able to see the structure in here. Okay, so now once we have our candidates, we can now continue. So if there's any error at all, so let's see, I'm using the 200 in here. So if there's any error, I'll just say return error fetching data. If it is a 400 or 500, or you are running the data so much that you have been rate limited, then you will just return an error at that point, or we just raise an error. I just return. It doesn't really matter which one I did. Now, once this is done, the next thing is to insert this particular candidate into the DB. Okay, so I can say maybe print candidate if you want. If not, I can just continue. It doesn't really matter which one I did at this point. I just do cursor.execute, and then let's insert into our candidate. So I'm just going to have a query in here, and I'm going to have insert into candidates. I'm going to get in the candidate ID as well as the candidate name, the party affiliation, biography, campaign platform, if I'm right, campaign platform, and the photo URL. Now, once this is done, just getting the values. I'm using percentile S to, that'll be how many? 1, 2, 3, 4, 5, 6, isn't it? 1, 2, I'll just copy this. 3, 4, 5, 6. Okay. Now, once this is done, I pass in the values as a tuple that I'll be inserting into that, and they are going to be a tuple of candidate. I get in the candidate ID. I get in the candidate name, the party affiliation, candidate party affiliation. In fact, I'll just copy the rest in here, and I'll just replace this with the candidate. Okay, comma this. So lazy. Okay, and the last one in here as the photo URL. Okay, so that is formatted pretty nicely for us. I'll just yeah, like this. Well, the formatting is returning into that. I'll just minimize this so we can have everything in one place. Okay, so finally we just do cursor.commit. I mean connection.commit rather. Connection.commit. Now this is going to insert the candidate into the DB for us. And if there is no candidate in the system, we are going to be inserting. But if there's a candidate in here, we are not going to be entering this particular code block. Now this is done. We can check this out and see if our tables are created and candidates are inserted correctly. So let's do that. Just do python main.py. And do we have any error message? No. If you look at our Postgres in here, go back in here, just look at the Postgres, PSQL Postgres, and I'm connecting to the voting DB. So if you look at the DB, we have our candidates, voters, and votes. So let's see if we have a candidate in here. Select start from candidates, and you can see each of these candidates. So we have Claude Davis, Abigail Robertson, and Jerome Ferguson as our candidates for this party. So management party is nominating Claude Davis. From their primaries, Savior Party, Abigail Robertson, and for the Tech Republic, Jerome Ferguson is going to be the one contesting for them. Good. So the next thing we want to do is generate our voters information. The voters information is very critical at this point because these are the people that will be voting for their respective candidates. So it is important we use maybe something that is easily, so we don't have ties. I mean, by the time you are voting, so we don't have, the run of the election, inconclusive election or something like that. So I'm going to be using 1,000 voters as my seed, well, as the number of voters in the platform. We can use any number, even you can go lower or higher than that, doesn't really matter. So I'm just going to go into this, and I'm going to say for I in the range of 1,000. So this is going to give me 0 to 999. Is there any error message in here? What's going on? Okay, so if this is fine, I already committed done. So why am I seeing an error message? Yeah, I'm using a try except, something like this. Yeah, it was in the indentation error before. So I just getting our voters into the system. So we have voter data. It's going to be generate voter data. And once we have our voters, we are going to be inserting them, insert voters, using the connection, the cursor, and the voter data that we generate. So each of the voter that is generated is going to be inserted in real time. Well, so let's quickly work on this before we continue. So in here we have Jeff generates voter data, and we are passing in the nothing. So it's just a function that we are calling, and once we call the function, the voter information will be generated. So I just have my response. It's going to be request. What am I doing? Request, yeah, .get. So I get in the base URL from there, and then if the response the status code equals to 200, then I'm going to be getting the user data and the response.json from there to getting the results, and I'll get the first argument from the results. Then I'm going to be returning a JSON that is going to be formatted the way I want. So the user ID, just like we have in here, is going to be this. I'll just copy that and paste it in here. The voter name is going to be the same as this. Well, it's going to be a different voter this time around. The voter name is going to be that. Okay, the date of birth, do we have it here? Nope. So date of birth is going to be user data. We have the DOB and then we get the date. Okay, so the gender is going to be user data, then gender. The nationality is going to be user data. We get the nationality from there. The registration number is going to be coming in as our user data, the login, and the username. Then the address is going to be, we're going to pass in the streets. By passing the streets, we get the city, city in here. We get in the state. Then we get in the country as well as the postcode. Country and the postcode. Okay. All right. So let's get those in quickly. So we have a formatted string of user data, and we get in the location, which gives us access to the streets. Yeah, this is going to be double quotes. Okay. And the last one in here. Yeah, we get to the streets and then get a number for the streets. We get the user data in here. We get in the location. We get the street location, the street, as well as the name. And that's what we need to get for that particular guy. So we just copy this guy. I'll just keep changing the street to city. No. Yeah, like this. So I'll change the street to city in here. States. Okay. I'll get the country. And for the last part, we get the postcode. All right. So finally, we just get into the last bit, which is the email. We have the user data, and we get the email address of the user. Excuse me. We have the phone number, which is the user data, and we get in the phone. Then we have the picture, which is the user data. We have the picture. Then we get the large picture. We have the registered age as registered, and then we have the age. Good. Now at this point, we've been able to successfully get in our user information, and so far there's no error message. There's no error in here. We should be good. So let's see if we can take this for a spin before inserting the voters in the DB. So let's just print just one record of this voter data, and we just break. Okay. So let's see. It says address is invalid. So because we didn't have a comma in here. If you run this again, good. So we have in our this is our candidate, but our user ID for the voter is here, Elijah Gonzalez in 1972, and this is an information of the Elijah. Good. So now we've been able to get in our voter. So far everything is fine at this point. We can proceed. All right. So now let's get the voter inserted into the system. Okay, I don't need to print it in here anymore, and I don't need to print in the candidates as well. I just delete that. Okay. Now for my voter, now once the voter information is generated, the next thing is to insert the voter in the DB. So let's do that. we are going to have a function called insert voters, and this is going to be taken in the function of dev. Insert voter, we have the connection, the cursor, the voter. All right. So now we're just getting the cursor.execute, and then we can have our insertion script, insert into voters. The tuple, and then we close in the execution script in here at this point. So we have our values, and then we pass in the data in here, and we should be good at this point. So the next thing we want to do is just connection.commit, and this should give us the right information that we need. This has been re-indented, so let's fix that. Good. So right now, we close this. All right. So we've been able to create our insertion script. So let's see if we can get one voter into the system. We just, once this is done, the next thing we want to do is to get in our Kafka producer. Now Kafka producer will be, we're using the Confluent Kafka package. So let's bring that into the system. So I'm going to have my producer. It's going to be a serializing producer. So let's import this from Confluent Kafka. And I'm going to be passing in the bootstrap servers. It's going to be localhost 9092. The port that is exposed by the Kafka. All right, so that's my producer for you. And I'll just come in here, and I can just get in my producer to produce the record into Kafka, and I can say produce. So our voters topic is going to be voters topic. The key is going to be voter data. I'm getting the voter ID from there. The value is going to be json.dumps, and we're getting the voter data from there. And on delivery, we want to get the delivery report. This is optional. You might want to add it if you want, just to know if your data is getting delivered or not, but you don't have to do that. So it's not compulsory, to be frank. So I have my error and I have the message. I just like to get in an acknowledgement message that the message has been delivered. Okay. So if there's an error, it says message delivery failed, and this is the error. And the error is going to be the error. Else, we just say print message delivered to the message topic. Okay. And the message partition. Right now, we are not using so many partitions, just a single partition that is created for us. Partition. So if you want to add partitions to multiple partitions to your topic, you can add that, by the time you are creating a topic in here. You can create a topic separately and pass in the partition, then pass in the topic name in here. But I'll be creating on the fly, so it's going to be creating a single partition for me. And that's really all we need to do for our producer. So we just maybe print something to show that something is progressing. So we say produced voter information, and the data that is produced is in that format. Just getting a formatted code in here. Maybe not. Let's yeah, in here. So we just do dot format, and I pass in the argument of the current index as well as the voter data. So the voter 1, something like that, or voter 0 to the end. So at the end of the day, we just do producer.flush to ensure that all the data is delivered. Good. I think that's all we need to do to get in our producer. So right now we've gotten in the candidate into the system, we've gotten in the voter at the party. So let's see if everything is working as expected. So I'm just going to run this Python main. So far everything is fine. It says there's an error. Okay, so it's not reaching this point. What's the issue? I think when it's inserting data, we have voters, voter ID, voter ID. So what's the error in here? So when we are creating our table, we have our voter ID in voters. So this should be fine. And by the time we're inserting voter ID. So let's see, print voter and maybe voter in here. So this is I'm using user ID, not voter ID. So let's change that. That's the error. So when I'm creating, I'm sure you probably saw that too. When you're generating the voter in here, generating voter data, instead of user ID, it should be voter ID. And everything should be fine. We have address underscore street. So in here, yeah, we are not, this is still a JSON at this point. So we need to break it down like this. I'll just copy this. In my head, I was having a SQL statement here. So I'll just do the same for this, the postcode as well. I think everything should be good here. It says tuple index out of range. So that means we are passing more tuple than the available arguments. So let's see. So we have 1, 2, 3, 4, 5, 6. So we have 1, 2, 3, 4, 5, 6. This is fine. Let's look at the voter. So when we are generating our voter information and inserting them in here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So it's not 16, it's 15. Okay. Yeah. So our voters are getting produced, and right now we have about 20 voters in the system. And if you look at our Postgres in here, select star from voters, and you can see them inserting successfully into the system at this point. So even if you want to do the count, you can do a count star in here or count 1 or whatever. So we have 95 records, 104. So it's inserting and we're going to 1000. On the same vein, if you go into a broker to see if we have a list of topics in the system right now, we have a voters topic. So the reason why at this point I'm not producing candidate information, party information, as well as the the two other informations, I'm not producing them to the topic, is simply because when I'm streaming, I'm going to be joining multiple streams together. So I want to reduce the workload that is going to be working on the system. But it doesn't really matter. You can choose to produce the data into the streams, and at the end of the day, when you are using your Spark stream to stream this data, you can join them together using the Spark stream. But you have to just be careful of whether you are using the append or output mode, depending append or the complete mode, or even the update mode, regardless of which one you are using. So you just have to be careful around that. I just wanted to put that out there. But right now I'm having the voters information. So if I want to see the content of this Kafka console, of that particular topic, I have Kafka console consumer, and I'm going to pass in the topic, which is the voters topic, and I'm going to be passing in the bootstrap server, which is the broker 29092, And then the final thing that I'll be saying, if I want to be getting that from the beginning, maybe not. I'll just, the latest information that is coming in, and you can see that, as it's being processed. So I don't need to start from the beginning. It's just going to mess things up and, list all of them into the system. But right now, I have all of these records. So we just wait a little while. We are in about 490 something, 500 records as of this time, and they are getting delivered into the topic. So according to our workflow, the accreditation process is done. We are done with the candidates and parties, and we are done with the voters. So the next thing is to start the voting process. Now, once we start the voting process, we are not going to be going for accreditation anymore. No new users will be created. So right now, we already know the system, the number of voters accredited across the Great Britain is 1,000. What we want to do right now is to go into the voting process of these accredited voters, and then they are going to vote in the platform. So let's create our voting platform. So we are going to say voting.py, and if you look at what we have in here, we have our voting. Okay. Now for our voting, we just need to let's say if the name equals to main. Well, all right, so this is the entry point of the application. So we get in the connection, psychob g2.connect. So, and then we say our host equals to localhost, the DB name equals to voting, user equals to Postgres, as well as password equals to Postgres. So we have our cursor, just like we had before, as a connection.cursor. And what am I doing? Cursor, if I can only type cursor. Okay, so as of this time, we've been able to connect to our Postgres. So the next thing is to get in the candidates that we're going to be voting for. Okay, so let's do that. So we have our candidates query. It's going to be cursor.execute. Now we say select star from candidates. Okay, so if we do a select star from candidates at this point, we just say candidates equals to cursor.fetch all, and we say print candidate. Okay, so if you run this, there's something I want to show you here. If you run this, we are going to have, you can see we are only having at this point we have Claude Davies as of this, but we don't know the title of each of these columns that we have. So there are two ways to this. You can either map these records individually to a particular index or a particular column, but we're not going to be doing that. We're going to be using a more mature approach on the DB to map it automatically, so we don't have to do the workloading and of the mapping into the code. So let's quickly do that. So in SQL or in Postgres per se, we have a particular function that you can use to transform that. So I'm going to say, I'll just write the function. It's called the row to JSON. Select row to JSON, and I'm going to be passing in the column, which is the column name, and it's going to be a select from there, and I'm going to pass this in, and I'll alias it as maybe column. Okay, yeah, cool. Yeah, so right now I'm saying select from this, but by the time you want to do that, I'm doing a select row to JSON, so it's going to get me the column name as well as the record of each of these candidates. Okay, so let's run this and see how it looks like. So if you run this again, and you can see we have this aligned pretty nicely. Okay, so if you want to, now this is an array of tuple instead of array of JSON. So if you look at each of these records, each records are put into a particular tuple themselves. So we just need to pass in the tuple, and then we can extract the candidate information from there. So I just say candidate, maybe 0 for candidate in this. All right, and this should probably fix that for us. And you can see we have an array of JSON at this moment. Excellent. So right now, we have our candidates. So we don't need to print them again. That is resolved. So we just say if the length of candidates is equals to 0, we raise an exception at this point. We say, okay, no candidates are found in the database. So we are not going to be continuing. But if there's candidates in the system, we can either say maybe print or something like that. Print maybe the candidates. Print candidate. Okay, so we don't have to do this, but I mean, you don't have to print per se, but if there's no candidate, there's no point in continuing the election. So we need the candidates to be in the system before we continue. Okay, so I'm going to have my consumer, which is going to be coming in from okay, it's not automatically resolving, so let's import that. So consumer is going to be coming in from from Confluent Kafka. Import the consumer. So we are going to be getting maybe Kafka exception and Kafka error, as well as a serializing producer. We're going to be using them shortly, so there's no need to coming back and reinitializing them. So we need to bring in our consumer configuration in here. So to do the consumer configuration, I think we should do that in here. So let's do that. We have our configuration. It's going to be our bootstrap server. Not bootstrap underscore server. Bootstrap.server is going to be localhost 9092. Okay. And then our consumer is going to be from the consumer group. And then we are going to be passing in the configuration. And because we are going to be needing the same information for producing as well as the consumer, so I don't want to repeat that. As much as possible, I have my group.id, and I'll call this maybe voting group. What am I doing? Voting group. Then if you want to start from the earliest, you can do that, earliest. Then we enable commit, enable auto commit. I'm putting that to false. And the reason for this is simply because I want to ensure that I'm starting from the beginning and it's not auto committing. So it's possible that we just need to handle the rest of the error message that is coming if there's any error at any point in time. Okay, so we have a producer. It's going to be a serializing producer, and I'm using the conf this time around. Okay, import that. Good. Okay, so finally we have our consumer ready to be put to action. So we are going to subscribe to a particular topic, which is called the voters topic. Now in the voters topic, we are going to use a try except in here, exception as a E, and we just say print E, just in case there's any exception. So if there's we are subscribing while this is true, so this is indefinite subscription anyways. So we get in the message consumer.pull, and we're passing a timeout of timeout equals to 1.0 as our timeout. So if the message is none, okay, I continue. Else if the message dot error, if there's an error, getting the message, I get in the message error code. And if the error code is equals to Kafka error, okay, let's bring this in. Dot partition EOF, that's the end of file. I continue. Let's bring this in. Yeah. And just minimize this a little bit. Else, if there is other type of error, I just say print the error message. Okay. And then break. There's no need to continue. We want all or nothing. So that is important at that point. So If there's no error, we just get in the voter, deserialized from the system, and we're going to be using the simple JSON, import simple JSON as JSON, message.value, and then we decode that as a UTF-8. Okay, now the chosen candidate, we don't have a candidate brought into the system in this section, so let's do that. We are going to say random the choice is going to be our candidate. We pass in our candidate. I mean, this is candidates in here. These candidates, we are passing in the candidates today. So we are going to have a single choice of candidates as at that time for that particular voter. So we structure in our vote as a voter, our chosen candidate, as well as the voting time that we're going to be voting. The customer is voting time, which is going to be date time. So let's import that from date time, import date time. Okay. So we have our date time .utc now .strf time. We just pass in the format. It's going to be year, month, day, and then we pass in the hour, minutes, and seconds. Okay, is it year, month, day, hour, minutes, seconds? Good. So now finally we just say our vote is going to be 1 by default. So right now we have our vote structure, and we can say if there's any error at all, we handle this at this point. So we say user, this particular user is voting for candidates, and the candidate they are voting for is this. So I'm passing in the voter ID as well as the vote. I mean, not voter, it's vote. What am I doing here? It's vote, voter ID, as well as the vote, the candidate ID. Okay. So finally, we insert this cursor.execute into our vote topic, as well as the Postgres database. So we say insert into votes, voter ID, candidate ID, the voting time, which is going to be a timestamp. The values are percentage S as 3 records in there. And finally, we pass in a tuple of a voter or voter ID, vote. Hey, why am I using voter for God's sake? Use vote. Vote, candidate ID, and vote of voting time. Okay. Now, I think everything should be okay, except we didn't have an exception in here as our E. Just print E. Maybe error, and then we print that. So now this is inserting into our Postgres. We just do connection.commit, and once we insert into the vote, we want to do a production into the topic. Now, the order really matters as at this point. If you commit before producing, you may run into an issue where the data is produced, but it's not being inserted. Maybe the user is trying to vote multiple times. So if you insert into Postgres first and there's a conflict on the DB, whether you are using, because we use a unique and a primary composite key. So if you try to insert into Postgres, as at that point, it's going to fail. So that means the production is not going to be done. But if you produce before inserting, you're going to have the data on the topic, but on the DB, it's not inserting. So that will lead to inconsistency in the system. So that is something you have to be careful about. And that's what is, influencing the way I'm structuring the code as at this point. So I have a votes topic. The key is going to be vote, which is the voter ID. The value is going to be JSON.dumps, and then we pass in the vote, not the vote. Then on delivery, it's going to be the delivery report. So let's just import this. There's no need to retype that. Okay. And we just do producer.poll, and we should be good. All right. So looking through what we have right now, let's see. Yeah, I think everything should be fine. So far, we have all the data printed out nicely, and we should be good. So now one final thing, if I run this is going to run through the data very quickly. So I'm not going to be running this right now. So what I'm going to do is I'm going to get in my Spark job in place so that by the time I'm voting, I can visualize this in real time. Okay, so I'll just leave this as of now, and maybe what I can do is comment this out and see how the structure of the data looks like before inserting or producing. But the problem with that is I'm consuming. So let's leave it as that, and we just continue. Okay. So finally, we just get into our Spark streaming, and yeah. So you just have to. We'll test this out by the time we are getting to our Spark streams as well as our Streamlit application. Okay. So now the voting is done potentially, and it seems the logic is correct if you look at it, unless there's an error that we need to fix. By the time we are running it, we are going to fix that. So now we just go into the other part, which is the third part of getting the Spark streams, listening for events that are coming in for our vote from our voting. Okay, which is the vote topic as of this at this point. So I just say touch Spark streaming.py. Now, Spark streaming, this is where we are going to be bringing in our Spark cap. So for our Spark, we need to install our package, pip install Pyspark. So we install Pyspark into the system. So let's import our Pyspark and the dependencies are required. So I'm going to be importing Pyspark, and if the name equals to main, as always, then we start. So we need to know the version of Pyspark that has been installed. Well, this gives it away, but in case you didn't see something like this, or you are not seeing something like this, the first thing you want to do is ensure to be able to resolve the dependencies that will be accompanying Pyspark, you need to print in your Pyspark version. This gives you access to the version of Pyspark that is currently Python Spark streaming. So you can see as Pyspark 3.5 is the one that I just installed and is the one that is running on my system. So any dependency that you're going to be installing is going to be related to 3.5. Don't forget, that is very important. If you use 3.4, you might be lucky that it runs, but there's no guarantee that you're going to have an accurate or correct information at that point. So you want to be sure that every dependency that you are using is 3.5. Okay. So I'll just comment this out for now. So let's initialize our Spark session. Our Spark is going to be Spark session. We are going to be importing this. Okay. Builder, and then we have our app name. The app name is going to be Realtime election. Maybe real-time voting engineering. Okay. All right. So we have our master. I'm using my local system, so there's no need to specify the master, because by the time I'm submitting my job, I'm submitting to my Spark cluster. So the cluster already is using a cluster. So if I use the local while I'm using it on the cluster, it's going to, lead to challenge on that. So I'm just have my config. Yeah, it should be in here, .config. And the config is going to take in the spark.jazz.package that I'll be using. So I'll be using org.apache.spark and Spark SQL Kafka. And in case you were wondering how I'm getting this information, I'm going to be showing you where to get it if you want. 2.13, 3.5.0. Okay, so if you go into Safari, and on Safari you launch up Maven repository, this guy, and in here you come to Spark SQL Kafka. You just search for that. You see Kafka 0.10 for structure streaming, and right now I'm using the 3.5 version. And if you look at the Maven, I have a group ID of this. Okay, this is my group ID, so I copy this and I replace that with this group ID in here. And the artifact ID that I'm using is this one, .13. And if you replace this, okay, and the version is 3.5.0, and the same thing here. Okay, so in case you want to get that, that is how to get it. I'm going to leave the link in the description as well, in case you want to just click on the link and get the jazz. So have the spark.jazz. Now, because we are going to be working with Postgres, we need to get in our Postgres Java JDBC, Postgres JDBC connector. Now, this connector is going to allow us to have a driver of our Postgres driver, and we can communicate in real time with Postgres. So let's do that. So to do that, you come in here and you say JDBC, what's the name again? Postgres JDBC driver. So you can come to jdbc.postgresql.org, and in here you'll see the PostgreSQL JDBC driver, and you can download this one. So I already did the download, so I'll just maybe download it again. Doesn't really matter. So I'm using Java 8. Well, you can use any of the Java version, but I'll recommend you use something like Java 8. So I just download that, and it should be in my download. So I'll just move that into my system in here. So let's get in my Finder, and I'll just bring that in from downloads, and this is coming in here. I'll just move it. Okay, refactor, good. Now I just brought in my jar file into here. So for me to pass in the jar files, so I'll just come in here, right click, copy absolute path in here, and I'll paste it here. Okay, and this is my my PostgreSQL Java package. So the next thing is to specify the adaptive enabled. You don't have to do this expressly, because by default it's going to most likely disable it. So, but I just want to disable it. You can check the documentation for the details. So, but what I'm doing is to disable adaptive query execution. Okay. So in case this is the Spark Kafka integration, and this is the PostgreSQL driver. Okay. If I can only type driver. All right. Now that is done. Okay. And this is where I'm initializing Spark session. Okay. Now our Spark variable has been established through our Spark builder configuration in here. So one final thing that I just need to add to this is to once I'm done with the config in here, I just need to add .get or create. Now this is going to create a session for me, and I can use this Spark variable as my Spark context by the time I'm running my code. Now I need to deserialize the data that is coming in from the topic into a particular schema. So I'm going to be specifying the schema. So I'm going to have a vote schema, which is the schema of this guy. If you can recall this schema here, everything in here is what I'm going to be deserializing. So I have my vote schema. So I'm going to be using the struct type to do that. So import from types. So okay, now we've gotten in the structure, the schema of the system that is coming in to the topic. Now we want to match in the data and deserialize it with the schema itself. So in our Spark Spark stream, so I'm going to have my vote data frame, which is going to be spark.read stream. So I'm going to be reading the stream of data that is coming in from Kafka. So I'm going to say the format is going to be Kafka. Maybe I'll just put this in a tuple like this in a bracket. Yeah. For some reasons, I don't like to be typing the backslash. Option is going to be bootstrap.servers, and the value is going to be localhost 9092. The option again is to subscribe. I'm going to be subscribe to a particular topic, and the topic is going to be votes_topic. If you haven't forgotten, that's the topic we are voting on. And the starting offset is going to be my earliest. So I'm starting from the beginning, and I'm going to be loading that. Now, one final thing is once I load this, I need to select the data as a string. So I can do that separately or do together. So I'm going to use it together anyways. So, but you can separate this part, maybe do vote_df equals to vote_df.select expression, something like that. But I'll be doing it together in here. So I'm going to be casting value as a string. Okay. Then you can select from there. I'm going to selecting from JSON, import this name. Yep. Then getting the column for value. Let's get that in column. All right. So I'm selecting from value, and I'll be passing that into the vote schema. So this is going to be formatted to a vote schema, and I'm going to be aliasing that as data. Okay. Then finally, I just select data.asterisk. Okay, that means everything from data in itself. So potentially, this is going to subscribe to the vote topic, get the data from the earliest function there, earliest record there, and then cast it as string, convert it to JSON, and select everything from there. So that is the first step. The second step is to convert the the timestamp of the voting time to timestamp, which is going to be votes df dot with column. So I'll just have in my voting time as a column for voting time. Then I cast that to timestamp type. Okay. And one final thing is to do another with column in here to cast in votes column votes dot cast as an integer type. So I think this is repetitive because we already did that in here as an integer type. But when I was trying this, for some reasons, it couldn't deserialize that as integer. So that's why I'm casting it again. So this is where we are doing our preprocessing, data preprocessing, type casting, and one more thing, we do a watermarking. So enriched votes df is going to be votes df dot with watermark, and we are going to have the watermark of voting time, and the delay is going to be 1 minute. Delay threshold is going to be 1 minute. So I think if you look into the documentation here, it says defines an event time watermark for this data frame. A watermark tracks a point in time before which is assumed no more late data is going to arrive. So if any data arrive, later than 1 minute, it's not going to be processed as at that particular voting time. But in 1 minute, we assume that all the data is going to be processed and delivered within that time. Now, this is where the meat of the streaming comes in, the aggregation of the data. So I'm going to have two aggregations in this section, but you can have multiple aggregations. And if you look at the code, I commented out some parts of the aggregation. So you might want to, fine tune them, uncomment them, run them. But the challenge that I had was I had less compute. I don't have enough compute to run the 7 aggregation in time. So it's slowing me down. So that's why I'm limiting it to 2 aggregations in this video. But you can increase the aggregation as many as possible. Or you can even separate your Pyspark jobs into several jobs, and you can submit them to the cluster, and they will be running independently at the same time. Otherwise, you can also scale up your compute and have multiple, a more capable compute that can process all the 7 pipelines at the same time. Okay, but I'm just going to be leaving it at 2. So I'm going to start with the aggregation. Aggregate votes per candidate, and turn out by location. I mean the voting information of each of the candidates. Okay, so I'm going to have votes per candidate. It's going to be enriched votes df. Then I'm going to be grouping by the candidate's ID, the candidate's name, as well as party affiliation. Okay, I need one more thing, which is the photo URL. So I want to display the URL or the picture of each of these voters or of the candidates on the dashboard. Okay, so I'm going to have an aggregation, and the aggregation is going to be a sum aggregation. I'm going to be voting. Alias that as total votes. Okay, now my sum in here is going to be considered as a sum. So let's bring in a sum as a function. So we say import from Pyspark.sql the functions import sum as underscore sum. This is a challenge because we're using Python, and sum in here is an inbuilt function potentially. So right now I just renamed that to underscore sum. So you might want to be careful so you can handle that as well before continuing. So the final one that I want to be handling as well is the turnout by location. The same enriched vote df. I'm going to be grouping this by the address dot state. Okay, then I'll just do a count and alias that as total votes. That's all we need to do. Now, the aggregation of the voters per candidate is done. So we have candidate 1, 2, 3, and the number of votes that is coming into the platform. How are we going to be structuring that and streaming it to a particular topic at the end of the day? So you can use different method, but I'll be using the update method in my case. So if you look at what I have in here, votes per, let me just write the code. Votes per candidate is going to be writing that to a particular topic, and this is going to be votes per candidate, select expression. And this time around, I'll just say to Kafka, it's going to be votes per candidate dot select expression. Now I'll be selecting this to JSON, struct of asterisk, everything in here as a value. Just close this as value. Okay. And I'll be writing this into my Kafka streams. Okay. Dot write stream. I just format that, and I can have something like this. Okay. So when I'm writing to the stream, the format that I'm writing this as is going to be Kafka format. The option is going to be Kafka bootstrap.servers is going to be localhost 9092. The topic that I'll be the topic that I'll be processing to or writing to is going to be called aggregated votes per candidate. Okay. Then I need to pass in one important factor in here, which is the checkpoint location. Checkpoint location. Now the checkpoint location is going to prevent reprocessing of the already processed data. Even if you stop our streams and we rerun it again, it's going to know which checkpoint it stopped from and where to pick it up from and continue. And if there's any error or failure, it's going to continue from the last checkpoint. Okay. So let's create a checkpoint in here. So I'm going to have make directory checkpoint, and I'm going to have checkpoint 1 and checkpoint 2. Okay, there's no checkpoints. Okay, so if you look at what I have in here, I have my checkpoints, checkpoint 1, checkpoint 2. So I'm going to be writing the first checkpoint as I'll just copy, copy path reference, absolute path, and I'll paste this here as my checkpoints for the first checkpoint. Now the mode is going to be output mode is going to be update. Now, why am I not using append output in here? It's simple. Because I'm doing an aggregation. What am I doing? Okay. So I'm not using append as my output mode because append is just saying once that comes in, append it as each record. But I'm using an update here. So if you're doing any aggregation with your transformation stream, you can't use append because of the aggregation in there. So you have to use something like update or maybe complete at the end of the day if you are done. But I'll be using update as of this time. So because each record is going to be aggregated over time. Okay. And I think I can just copy this and replicate that for turnout as well. The turnout is going to be turnout per votes per candidate. So I'll say turnout by location to Kafka, and I'll change the name, the topic name, to aggregated turnout by location. Okay. The checkpoint is going to be checkpoint 2 as well. Now finally, I just need to await the termination of this. Await termination for the streaming queries. Okay, so it's just going to be votes to Kafka, await votes per candidate, await termination, and turnout per location to Kafka, await termination. Okay, good. So now let's take this for a spin and see if everything is working as expected. Okay, so I'm going to have I'll be running my voting as well as streaming. So I just need to throttle this a little bit so we don't just process everything at once. So I'll just have time.sleep. I'll say 0.5. So it slows it down a little bit. I'll say Python voting.py. No, I'll do it here. Python voting.py. And then I can start my Spark streaming as well. So let's see what is going on. It says the voting is already in progress. It says what's going on. Read writer, vote.df, Spark stream. So he couldn't read the stream. So what's going on? Vote.df, Spark dot read stream, Kafka option. So what's the error message in here? It says fail to find source Kafka. Please deploy application as per development. Yeah, let's see what is going on with this. So it couldn't, was he able to download that? Okay, the Apache Spark package, and it should be packages. I think that's why. If I run this again, because it didn't resolve. Yeah, I think it's because it couldn't resolve this particular dependency, is it not? It says that data frame object has no group by, but right now the dependency is resolved. Good. So let's see why the error is coming, where the error is coming from. Yeah, I can see this is an error from my side. It should be grouped by capital B. I don't know how I missed that, but for some reasons I did. Okay, so group by. Okay, I think I should save this and rerun that. Yeah, I think everything is fine. And yeah, it's processing. Lovely. So if you look at this, is automatically going to be created, even though it said error while creating while fetching metadata for this correlation ID, and the leader is not available. The reason why the leader is not available is because I didn't create the topic beforehand. So that's why you are seeing that error message. But it's something that is automatically handled by running and creating the topic itself. So if I look at the list of topics that I have in here, you will see that I have aggregate turnout by location, aggregate turnout by candidate. So if I want to see what data that I have in each of the candidates information, if I run this, you will see that as of this time, this is 196 and Jerome Ferguson is currently here. So we are going to rerun this voting process, but this for now, we are just going to be, continuing. So it looks like everything is working as expected. Let's continue with our Streamlit voting process. Okay, so let's finalize on our dashboard. Right now, the aggregation is going on in the background, and what I'm going to do is I'm just going to stop the process from continuing as of this moment, because it's going to affect my compute power. So I'll just stop it for now. I'll stop voting as well. And okay, so once that is done, I'll continue with my dashboard. Now for the dashboard, I'll be using the Streamlit. So let's import Streamlit. So I say pip install Streamlit. So if you go to Streamlit in here, so if you want to install, I think for you to try Streamlit now, it says pip install Streamlit, and you can just copy this and I'll paste that in here. So right now, Streamlit is getting installed as part of my package. Once that is done, then I can start my dashboard creation. Okay. But right now, all of our voting process and the aggregation process is working as expected. Okay. So now, To start with our Streamlit application, I'll just touch Streamlit app.py. Now in our Streamlit app.py, we are going to be bringing in some packages that we've already installed, and we can now install new packages that are going to be supporting our process. Okay, so I'm going to be importing Streamlit, import Streamlit as ST. Now, the way Streamlit works is for us to get in our UI, written out. So once I have Streamlit as this, I can basically say st dot maybe write, and I can say real-time election voting dashboard. Really, once I do this, the next thing is to just say Streamlit run. The reason why you are seeing this particular error is because it's using a different Python based directory right now. So if I do which Python, you will see that this is where the Python is coming from. But by the time it's trying to read, it's reading from this particular Python 3.9. So I think what I'm going to do is I'm going to just deactivate for now and source this again. Deactivate. I'll source this again. Source pin activate. I think if I run this again, Streamlit, run this. Yeah, that's it. So I just need to come back to here. I just come in and you can see that I have my election voting dashboard. Okay, something like this is and you've gotten Streamlit installed and running in just a few seconds. Okay, now let's now incorporate our Kafka and everything into the system. Okay, so I'm going to have a function. I'll just remove this for now. I'll just say dev update data, where I'm going to be writing all of the scripts that I'll be working with today into that function. Now inside my update data function, I'm going to have my last refresh. The last refresh time is going to be st.empty, more like a empty placeholder. Then I'm going to put in a text in there. Text is going to be what? The text is going to be last refreshed at what time. I'm going to be having the time.strf time of year, month, year, month, percentage M, percentage D, percentage H, percentage M, percentage S. Okay, year, month, day, hour, minute, second. Okay, as my format in there. Now we need to fetch the voting statistics for fetch voting statistics from Postgres. Okay, so I'm going to have fetch voting stats function, and for us to do that, we have a function called fetch voting stats in here, and in here we're going to bring in our scop g2 scop g2.connect. Okay, and this is going to give us connection as usual, and then we just need to bring in the required parameters in there. So we say the host equals to localhost, the DB name equals to voting, user equals to Postgres, password equals to Postgres. Let's get in the cursor, connection.cursor, as usual, cursor. So now we need to get in the total number of votes as well as the total number of candidates, voters, and the candidates. So we say fetch total number of voters, as well as fetch total number of candidates. Okay, so to do that, we just do correct cursor.execute execute. We have select basically count star voters from voters. Okay, we don't need that. Automatically is added. We just copy this, and in here I'll call this voters count, and in here I'll call this candidates count. Okay, from candidates. And that's all we need to do. We just do candidates count equals to cursor.fetch 1, and we get the first index there. We do the same in here. We say voters count equals to cursor.fetch 1, and then we do 0 there. Okay, finally we just return voters count and candidate count. Return these two, but now we need to do something here, because with the way Streamlit works is each time it refreshes, it's going to run every script on the same page at the same time. Well, it's going to run them again and again. So if we are refreshing every 5 seconds, that means each time we refresh, we are going to be running a query against our DB. What if we are refreshing every 2 seconds, every second, regardless of what is going on in the background as well? But what we want to do is we want to just fetch this information once and cache it in memory. So in case we want to refresh again, we're not going to be refreshing every now and then again and again and again and again, if that makes sense. So what we're going to do basically is use a simple annotation in here called st.cache data. Now, what this is going to do for us is until we refresh this cache, all the data that is coming in here will be static, basically. So that's what we want to do. Now, this we just we fetch it in here, then we get in our voting statistics into the system, which is going to be our voters count as well as candidates count. Okay, now let's display this. Display the statistics. Okay, so we are going to have st.markdown, just our markdown for triple lines. Okay, and I think I should use 3 quotes for this. Yeah, just for column 1, we have column 2. I want to display this on the dashboard in 2 columns. So I'm going to have column 1.metric is going to be total voters as a voters count, and column 2.metric is going to be total candidates is going to be candidate count. Okay, so once we have this, if we go to our dashboard again and we say always rerun, you will see what we have on the UI. So far everything is working as expected. Let's see. Okay, right now we've not called the update data, so let's call it update data, and that should display it for us. Always rerun. We have the last refreshed, good, but it says the attribute has no fetch one data. Fetch one property. So that means my syntax is wrong. Let's see what I did wrong. Fetch one and fetch one. Okay, if I refresh this and boom, nicely we have 1,000 voters and 3 candidates. That is excellent. Now let's get in the header, more like a title, and from there we continue. So before we run our updates data in here, we just have a st.title, and we say real-time election voting dashboard. Okay, and that's all we need to do. Let's get in our topic, because we are going straight for topic next. Kafka next. So we are going to have our aggregated votes per candidate. Okay. And if you look at our dashboard, it's looking really nicely, sitting there pretty nicely right now. So one other thing that I want to bring into the picture is the refresh, but that will be after we've been able to consume data. We want to consistently refresh the data and bring in data as they're arriving. So right now we have our total voters and the voting metrics into the system. So let's get in our consumer. Okay, so we are going to have a consumer, and then we are going to say create Kafka consumer with the topic. What's our topic name again? Topic name. So let's create a function that does that. So we are going to have create Kafka consumer, and we have a topic name. So the topic name that we pass in there is what we'll be using as our topic to consume data. So we have a consumer. It's going to be Kafka consumer. So we bring in that from, excuse me, I'm using Confluent Kafka. So I'll be using the Kafka Python for the consumer in here. Pip install Kafka Python, and I'll just bring in our Kafka consumer from there. Okay, so the Kafka consumer is going to be using the topic name, the bootstrap servers is going to be localhost 9092, auto offset reset is going to be earliest, value deserializer as well. Value deserializer is going to be a lambda function of xjson.loads x.decode the UTF-8. Okay, and we just need to bring that in from simple JSON. So import simple JSON as our JSON. Okay, and where are you? Create Kafka consumer. Okay, good. So right now we just return consumer. So this is creating our Kafka consumer for us. But what we also want to do is consume the data and fetch data from there. So let's quickly write the function that does that for us. So we say fetch data from Kafka. So we pass in the consumer to that, and we're getting our messages, which is going to be consumer.poll. We just poll for timeout in MS. It's going to be 1000. That's more like a 1 second. Then the data that is fetched is going to be an array. We just do for message in messages the value. Basically, we just say for sub message, if there's any in message, we just do data.append sub message dot value, and we just return data. Okay, so again, what we're doing basically is just to get the message value, and for each of the message, we append the data. We append the message into the data, and then we just return the data. Okay. And if we go to our function just here, where is it? Yeah, in our consumer in here, we can basically just bring in the table and the consume data. From there, we can say, where are you? Consumer, and we can say data equals to fetch data from Kafka with the consumer itself. Okay. So the results that is brought in is going to be converted to a data frame. So I'm going to have pd.dataframe as data. So let's import our pandas into that. Import pandas as pd. Good. And yeah, Finally, we've been able to do that. But in here, if you look at Jerome Ferguson in here, Jerome has total votes of 196. If you look at Jerome Ferguson at this point again, he's having 208. That means there's a progression from 196 to 208. And for Robert and Abigail, Abigail has 182. And here she's having 192 at this point. The same thing happens with Cloud Davidson. He's having 202 at this point. So if we are consuming the first time with these 3 records here, the next time we are consuming, we should be consuming these 3 records, if that makes sense. I hope that does, really, because that's the way we are going to be structuring our consumer in this time. Okay, so now we can proceed to get the leading identify the leading candidate. Okay, so how do we identify that? So that's the whole reason of or the main purpose of putting it in a pandas data frame for us to be able to identify. So we have our result. It's going to be results.locate results.group by the candidate ID. And then we are getting the total votes. So what I'm doing is to get the maximum total votes for each of the candidates at every time I do a refresh. Okay. So the leading candidate is going to have the latest information or the highest record, which is going to be results and the total votes from there. And I get the IDX max as well. So this gives me the leading candidate information. So if I want to display the leading candidate information, I do st.markdown. Okay, then st.header. I put in the leading candidate as well as the columns that I want to be column 2. I want to be representing the data as columns. So I'll be having 2. Then with each of the column, I'll specify the data that will be there. I have my st.image, and then the leading candidate, I get the photo URL of that person, photo URL, and then the width of that image is going to be 200. Then for the second column, with column 2, I'm going to have an header, st.header. I'm going to get in the leading candidate name, candidate name. Okay, then I just put in the sub headers and all that. Okay, I just say st.sub header, leading candidate, and I have party affiliation. I have st.sub header, and I have my total vote. It's going to be this, the format, and I'll pass in the leading candidate's total votes. Okay, so let's see how that looks like on the UI. Okay, so if I refresh this, now it says attribute dictionary object has no value, and that's from, where is that? Fetch data messages the value. Okay, so let's undo that when there's no value. So when I'm consuming data from Kafka, how am I consuming it? I have my messages, consumer in here. I get the value. It's values, really. Values, okay? I don't know how I missed that. Oh, I think it's a typo on my hand. I just do a refresh, always rerun. Yeah, we're consuming the wrong topic. This is candidate, not candy double D date. Okay, I just need to do a refresh. and we should have yeah, good. So I just stop this, not the streaming. I continue the Streamlit. I just stop this and I stop this. Okay. So yeah, so you have to be careful there. That's an error, the typo from my hand. And yeah, so we have this, and on the UI, I do a refresh. Is our Streamlit app running? So I just do a refresh there. I do a refresh here, and you can see the leading candidate. So the leading candidate here is Jerome Ferguson from Tech Republic Party, and this is the total vote of the leading candidate. Good. So right now, these are the records that are coming in for each of the candidates, and each time it keeps growing. So what I want to do is remove this print result from here. Okay. Now we've been able to get in the leading candidates themselves. What we just have to do next is to display the statistics and the visualization. So I have display the statistics and visualizations. Okay, so I'll just do st.markdown. We get in the header for the statistics. st.header is going to be statistics, maybe voting statistics or something like that. We have the results. It's going to be results. So we just select the columns that we want from that data frame. So we have the candidate ID, candidate name. We have the party affiliation. We have the total votes. Then from there, each of these results is going to be, there's going to be an index, maybe the index of the production. So we are going to drop that index. So we have the reset underscore index, and the drop is going to be true. Okay. Now our data frame is being formatted properly right now. We just need to display the bar charts and donuts hey donuts chart. I hope I can just type chart. Okay, donuts chart. All right, so we get in our first and second column. Column 1, column 2 equals to st.columns, st.columns, and it's going to be 2 columns. Okay, so now the first column is where we're going to be having the bar chart. The second column, the donuts chart. So we have with column 1 as our bar chart figure. It's going to be, we are going to be having a function to plot colored bar charts in here with the results. And we're going to be doing st.pyplots for the bar figure. We're going to do the same for donuts with column 2 as we just maybe copy this and paste that in here, and that's going to be donut figure, and we change this also to donut figure. This maybe not colored. It's just going to be plot donut chart. So let's create these two functions. Okay, so the first one is def this with the results in here. For the colored bar chart, we have our data type. Data type is going to be data underscore type. It's going to be results, candidate name. So in case you want to have other types and you want to use the same function, you can just pass in type as an argument in there, and you can switch between the different types. But I'll just leave it at this once for now. Colors equals to, for us to get the colors, we get in the PLT from in here we have a import matplotlib.py plot as a plt. So this is going to come in here as plt.cm.viridis, and we need to bring in our numpy linspace. Numpy linspace is going to start from 0 to 1, and the length of data type is going to be the argument in here, data type. Okay, and then we have plt.bar data type and the results of votes, total votes, and the color is going to be passed in here as color. Okay, it's just to add, we have our bar chart already. It's just to get in our X and Y axis. So X label is going to be candidate, and the Y label is going to be total votes. Title is going to be vote count per candidate. Xticks to rotate the value in there by 90 degrees. Rotation is going to be 90 degrees, and they just return plt. Okay, that's for our bar chart. For our donut chart, it's similar, but it's a little bit different. So I'll just have in def plot donut chart, and we just pass in our data, which is going to be the data, and maybe the title. I'll just leave it as data for now, and just getting the labels. The labels is going to be labels. It's going to be a list of data for total, for candidate name. Okay, and we get the sizes. It's going to be data total votes underscore votes. Then we have the figure. The AX is going to be plt dot subplots ax.py. We have the sizes. Labels is going to be the labels. The auto picture is going to be auto pct is going to be percentage 1.1.f as the formatting, and percentage. Okay, so it gives us access to maybe 10%, 20%, or something like that in percentage. Okay, and if there's a dot, it's going to be one decimal place, and the start angle is going to be 140. The axis is going to be equal, and we have plt.title. It's going to be the title that we are going to be using. The title is going to be the what should I pass in as the title now? Candidate votes, something like that. Okay, then we have return the figure. Okay, and this should solve the challenge for us, and we should be good. So let's see if everything is working as expected. I just formatted that nicely. And on the UI, if we come back in here and do a refresh, we have candidate ID not in index. Candidate, hey, candidate, where is that? I have this in the results. Where do I have that? Candidate, okay, candidate, okay. I just refresh this. It says rectangle dot set got an unexpected argument of colors, and that's from plot bar chart, and I'm passing in the bar chart of colors. Okay, so let's see what we have in the error message there, which is plot bar chart. It says we have a colors in here. So I'm passing in the bar, data type, the results, total votes, and the colors. I think it's usually color, not colors. I just need to refresh this. Ah, nice. Okay, good. So right now we have the voting statistics, but one other thing is it's a little bit annoying to be refreshing this every time. So let's bring in a package that helps us to do that. We do pip install Streamlit auto refresh. So for the auto refresh, you just need to pass in the the frequency of the auto refresh. You can look at the documentation for the auto refresh. But what I'm going to do is I'm going to put that in the sidebar. So I'm going to have a function called sidebar in here. And in my updates, before my update, I'm going to have def sidebar. And in my sidebar, I'm going to have my session state. I'm going to have if st.session state.get the latest update is none. st.session state the last update is going to be the time, the current time. Okay, so let's create a slider to help us with that. So we are going to have the refresh interval. It's going to be the st.sidebar.slider, and we pass in our refresh interval in seconds, and we can have 5, 60, and maybe 10. 5 to 60 in the progression of 10. We have the st auto refresh. Okay, let's bring that in, import that, and we have interval. Is going to be the refresh interval single multiply by 1000, and the key is going to be auto. And we need one other thing, a button to manually refresh the data. So if the st.sidebar.button refresh data, I just have that as my update data. So what I'm doing basically is to say, if you click on the refresh button, update the data. Otherwise, automatically update this every 5 seconds. Okay, so the 5 seconds is going to be used as the default seconds as for the update. And you can see right now, if you look at the time that is doing the refresh in here, so let's see, right? Sorry, I mean 10 seconds. So it's going to be 5 to 60, but every 10 seconds. So if you look at the time, I have 13:44:29. So the next one is going to be in 39. All right. So you can see now. So that's the time it takes to refresh every time. Good. So I don't have to, manually refresh this anymore. And if I want to refresh right now, I just click on that button and it automatically refreshes this for me. Okay. Good. So now that's my voting statistics. Okay. I think I just do a refresh. Yeah, good. Now, I have my voting statistics ready. Now, the final thing that I want to do is getting the data paginated in the right order and placed in a table so I can see the details of each of the candidates as well as the locations that the voters are coming from. So let's quickly fix that and continue from there. So I have, at this point, I have my my donut and the bar chart, printed pretty nicely there. So the final thing that I want to do before I continue there is to, print the table results. Okay. So I get the results in there and I just I just always rerun that, and you can see the candidate name, party affiliation, and the total votes for each of the candidates. All right. So finally, I just need to get in the location and consume that data. All right. So I just do the fetch data from Kafka. on aggregated turnout by location. So basically the same way I consume data from here is the same way I'll be consuming the data for the location. So I just have location consumer. It's going to be the create Kafka consumer. I'll just reuse that. And I'm using the aggregated. And if you come in here and get the location, I'll just copy this and paste it in here. So the location data is going to be to fetch data from Kafka with the location consumer, and the location result is going to be pd.data frame for the location data. Basically just repeating what we had earlier. We just do the identification of the maximum, the max location identification. So we just have location result. It's going to be location result.loc. The same way we located the other one by using the IDX max. So we have the location result.group by the state. You can group by the city if you want. I'll just be using the state. I want to limit the, or even the country, regardless. So I get the count from there, IDX max. Okay. Then the location result is going to be, we just reset the index, and drop true. And finally, we display that, display the location-based location of voters. All right. I just do st.header and the location of voters. Then I'm going to have a function. This function is copied and pasted from the Discourse forum. So I just modified it a little bit. So I'll just copy and paste it and talk through what the content of the function looks like. Okay. So in here, I'll just create a function just above here, maybe above the sidebar in here. So let's talk through this. So what I have in here is the paginate table. So what it does is to create 3 columns for the top menu. So in the first column, we are going to have the sort data, whether yes or no. If you are yes, or if you click on the yes sort, we are going to have a top menu for the 2 other columns saying sort by the columns and the direction and the table data of ascending or descending order. And that will be your the first for the first row there. Now for the data itself in the table, you are going to have a pagination of a container, and in the bottom you are going to have these columns for 4 columns. So the first column is going to be the first this column 2 is going to be the page size. The total page is divided into equal sizes, or the equal number of the page size, which is the calculation that is happening in here. And the current page is the current page of the minimum value, depending on the value that you set in there, as page 1 or something like that. And the bottom first for the first record is going to be the current page of the total pages. Now we just need a split frame. The split frame is the cache data of let me show you. The split frame is just to split the data frame into the number of rows that you selected. So if you select 10 records, it's going to split the data frame into 10 records per page. Okay, and that's basically what the function is doing. So it's just to help us paginate our data frame in there. So yeah, and I'm using the st cache to cache the data frame, so it doesn't it's not too heavy for our system. And that's what is happening in the paginate table results in there. And finally, we just need to update the session state, the last refresh time. We have st.session state. The last update is going to be the current time. Okay, good. So let's see how that looks like on the UI. So far, there's no error. So it says we don't have a state, which is the message that is coming from where? Update data in here. Address. Okay, so let's see what address is coming in from our location. So what do we have in here? Print location results. And let's see what data we have. In the terminal, come in here to the bottom, and we can see I think I'll just clear buffer and just wait to do a refresh in here. Refresh data. Yeah, we have a state in here. So so we have our candidate name. So what I'm going to do is I'll just drop the table and reprocess everything again. So just quickly do that. I'll just come in here, Kafka. Let's list the topics. Okay, so let's delete Kafka topics, delete, and then we pass in the topic name. The topic name is I'm deleting this. Okay, I'm deleting the one with a single D as well. So we can start from the beginning. I'm deleting, let's delete this. And I'll need to stop the Streamlit. Okay. Yeah, I need to stop that. I need to delete this other one by location. By location. I need to delete the votes as well. Votes. Then finally, in my what's the name? In my Postgres, I'll drop the table, drop table voters, votes. And if you look at this, there's no voters anymore. And what we are going to do basically is comment out this part where we're creating the table in our main function. And I'll just, yeah, I'll just have this like this and comment out the rest of the code. Comment this out and Python main. So the table is created again. And I just need to, in my voting, Python voting, and in my Spark streaming, Python Spark streaming, and we can restart the Spark streams again. And if we do a refresh this time around, yeah, because I already stopped the Streamlit, so let's run the Streamlit again. Okay, and if I do a refresh in here, restart. So we still have candidate ID. So let's look at what we have in our topics. Do we have any error messages from voting? Yeah. Yeah, because of our checkpoint. So let's delete our checkpoint as well. I just delete the checkpoints, checkpoint 2 as well. And I need to just rerun that. So it was a clash of checkpoints before. Okay, so it's aggregating again. And if we look at our broker in our execution in here, and I list again, you can see we have the location as well as the candidate, hopefully. Good. So if I'm consuming from the location, you'll see the locations that we have. Yeah, perfect. So this is the locations that we're supposed to have. And right now, Claude Davis is the leading candidate. And right now, the locations of the voters and the information are getting inserted. So yeah, Abigail Robertson is leading the package. So I think it's time for commentary. Oh my God, Claude Davis just overtook Robertson. The management party is leading with 63 votes. And let's see, is anybody going to be leading again? Okay, let's see. Jerome Ferguson is coming up. He's coming up and is trying to overtake Claude Davis. Okay, I'm not good at commentary. All right, so but basically, I think right now we've been able to get in the location of the voters, the voting statistics, the leading candidate, and the total votes for the leading candidate. And you can see the records being produced each time. But it looks like Claude Davis is leading the package from the voting by maybe around 11 or 16 records, so that's thereabout. But it looks like other voters are still closing in. So if we just wait a little bit, somebody might overtake Claude Davis, and it looks like Jerome Ferguson is going to do that. Let's see. We just wait a few seconds more. Yep, I knew it. Jerome Ferguson took the lead and is from the Tech Republic Party. And it looks like the tech people are going to be the one leading this election. So I'm going to just do a pause and play in here for once we reach the end of the election voting process. We are going to see who the winner is and what the gap is at which they are leading. So let's wait and see how that looks like. And here we have Claude Davis eventually won the election, and 342 is this score. And if you look at the addition of all of them, we have 342 plus 337 plus 321. That gives us 1000. So it looks like our code is correct, and our output is the aggregation is fine. And this is the how the voters breakdown looks like for each of the locations in the UK. So if you look at page 2, yeah, you have page 3 in there. Yeah, and that's how it goes on and on and on and on. So yeah, we've been able to do that, do justice to that. Now, you may also ask a question in here that why don't we use other visualization UIs and all that? Yes, we can. And in the channel, we've done justice to that. We've used Elasticsearch as our real-time visualization dashboard. We've used Tableau as a visualization UI before. There's a Looker, Power BI also as well that you can also use as much as possible. Before you go, if you have not subscribed to the channel, kindly subscribe to the channel, like and share, and make sure you turn on the notification bell so you don't miss out on any of these videos that are coming out. I have a lot of packages that are coming in the package. And also, we have a community now. If you want to join the community, you can click the join button in the channel section to join the community, and also try to participate in the community polls, because that's where you can decide which kind of video is going to be coming out next and how the video is going to look like, how you want it, whether it's a cloud series, it's a Spark streaming, Apache Flink, or any other data engineering topic that you want me to cover. So let's do that in the community section. And if you have any feedback, please drop them in the comment section, and I'll see you in the next one.